welcome to the lecture number 8 of fuzzy sets, logic and systems and applications. In this nomenclature, some of the terms that we have already discussed, remaining nomenclatures that we will be discussing in this lecture. And as I mentioned, the support, core, crossover points, height, normality, subnormal fuzzy sets, all these terms in the nomenclatures have already been covered, and in today's lecture we will discuss the remaining terms in the nomenclatures used in the fuzzy set theory. Now, by now we understand what is a normal fuzzy set. So, normal fuzzy set is a fuzzy set which whose height is 1. So, if we have fuzzy sets whose height is not 1, let us say, and we would like to increase its height up to 1, or in other words, if we say that we would like to normalize a fuzzy set A. So, let us see how we can do that. So, if we have a fuzzy set A and A is a subnormal fuzzy set. So, if we have here, if we have a fuzzy set A which is subnormal, this fuzzy set is subnormal, and if we would like to normalize this fuzzy set, it means we would like to increase the height of this fuzzy set up to 1. So, here we can better understand this normalization by taking the examples, and one of the examples is here. So, if we take a fuzzy set here A which is subnormal fuzzy set, we see here this is subnormal fuzzy set, and so when we say subnormal means none of the elements here present in this fuzzy set has its corresponding membership value 1. So, we can clearly see here that this fuzzy set is, this A fuzzy set is a subnormal fuzzy set. Now, we would like to normalize this fuzzy set. So, we first find the height of this fuzzy set, and height of this fuzzy set is 0.8, because the maximum of all the membership values present in this fuzzy set is coming out to be 0.8, which is here. So, we have the height of a fuzzy set now, and then simply we divide this fuzzy set. So, when we say we divide this fuzzy set, it means we divide the corresponding membership values. So, this has to be noted here that like the first element in the fuzzy set A here, and the corresponding first element here in the fuzzy set A dash, which is a normalized fuzzy set. So, the membership, only the membership value is normalized. So, we need to understand that the generic variable value which is 5 here remains as it is. So, 5 remains as it is, but the corresponding value is normalized, corresponding membership value is normalized. So, how is it normalized here is, so earlier the 5 has its corresponding membership value 0.1. Now, if we divide it by 0.8, this becomes 0.125. So, this way the corresponding membership value is changed, and similarly 6 will have 0.5, and then 7 will have 0.625, and similarly all other points will have its corresponding membership values normalized. So, clearly here in, if we see here, 8 will have in A dash, 8 will have its membership value 1, which earlier was 0.8 in the A membership fuzzy set which was a sub normal fuzzy set. So, now we see that the A dash is the normal fuzzy set, and normalization process we understood very clearly. So, when we say here A divided by height of A, it means that we are dividing the respective membership values, the generic variable values are never normalized. Now, coming to fuzzy singleton. So, what is a fuzzy singleton? In fuzzy systems theory is a fuzzy set whose support is a single point, and of course, in the universe of discourse capital X, and so the support is a single point, and then there is another condition, this single point should have its membership value equal to 1. So, if this condition is satisfied, we call the corresponding fuzzy set, the fuzzy set for which this condition is satisfied is a fuzzy singleton. In other words, a fuzzy singleton is having core with only one element in its set. What does it mean? It means that if I have a fuzzy set and if we try to find the, if we are interested to know whether this fuzzy set is a fuzzy singleton or not, then we will quickly try to find the support, or I would say a core. So, if this core is a single value, then the core is the single value and the support is also a single value. So, it means what? It means that a fuzzy set which has a single element. So, the support is a single value and the core is also a single value, but if the support is a single value, it should have its mu equal to 1. So, this way here if we see that if we have a fuzzy set A which will be a fuzzy singleton when the corresponding x here. So, if we take a support here will be only one value which is x 1, and this at this x 1 will have its corresponding membership value 1. So, support. So, you see here the support of A is nothing but x 1, and of course, the support has a single element and the core is also a single element. So, in both the cases we have x 1 only. So, this x 1 this kind of fuzzy set is called a fuzzy singleton. Now, let us understand the alpha cut of a fuzzy set in fuzzy systems theory. So, alpha cut or alpha level set of a fuzzy set is a crisp set that is defined as A alpha is equal to the set of all the x for which the corresponding membership values are more than or equal to alpha. Alpha can be any value in between 0 to 1, it can be 0 also. So, let us now try to understand what is alpha cut of a fuzzy set. So, if we have a fuzzy set A here, this is a fuzzy set A, and if we are interested to find the alpha cut of this fuzzy set. So, if we choose to have my alpha like this is nothing but the membership value alpha. So, the corresponding to this we try to find the generic variable values. So, which is here in this case we have small a, and then here if we extend this we we will have another point here, which is another point of the generic variable b. So, we will get two generic variable values which are here a and b. So, a and b will correspond to the values the generic variable values at which we have membership value alpha. So, if we take alpha, we have to see whether the membership value is alpha or not, but this alpha, as I mentioned, can be any value in from 0 up to 1. And please understand that when we talk of alpha cut, so we are not interested in only equality, but we are interested in we will have a collection of all the generic variable values for which their corresponding membership values are more than or equal to alpha. So, in this case all the points in between, even including a and b, will be included. So, that is why we are showing this all these the alpha cut. So, all the values, the collection of all the values in between right from a to b, and please understand that a has been showed by a solid dot and b also has been shown by a solid dot. So, it means what? It has this line will include all those points, all the points for which we have the membership values, corresponding membership values either alpha or more than alpha. So, this way we understand alpha cut. Now, if we are we have another nomenclature which is another nomenclature that we use here is a strong alpha. So, if we are interested in finding out a strong alpha cut, so everything remains same except the quality goes away. So, if we are interested in a strong alpha cut, so a strong alpha cut is represented by a alpha and another dash is put here. So, a alpha dash is equal to collection of all the generic variable values for which we have the corresponding membership values more than alpha. So, in this case here, if we take the same example as we took in the alpha cut case. So, instead of this solid dot, here we will have the hollow dot. What does this mean? That we are excluding the quality condition, means this the generic variable value a and b will not be included, because at this point here alpha is exactly equal to the membership value is exactly equal to alpha. So, we will take only those values of the generic variable for which the membership value is more than alpha. So, more than alpha will be getting by this line. So, because of that the terminals of A and B will be hollow. It means that these points will not be included. The start of A will not be included, because here the alpha is the membership value is alpha, and here at B also the membership value is exactly equal to alpha. So, let us now take an example here to better understand alpha cut and strong alpha cut of a fuzzy set. So, here is an example. So, if we take a fuzzy set A for a universe of discourse capital X, and if we are interested in finding out a alpha cut, and this alpha let us say is 0.4 here, and it could be any value in between, as I mentioned that right from 0 to 1. So, let us now try to find the alpha cut of this fuzzy set A, and the alpha, the value of alpha is equal to 0.4. So, we can represent, as I mentioned, this alpha cut by A subscript 0.4. So, let us now try to see here in the fuzzy set A. So, we see here this point in the fuzzy set. So, 6 we will have 6 and then 7 and then 8, 6, 7, 8 and then 9 and then we will have 11, 12, 13, 14, 15. So, all these are the generic variable values for which the corresponding membership values are either 0.4 or more than 0.4. So, this way we can write A 0.4. Now, if we change the value of alpha to 0.6. So, my A 0.6 cut of A will be the collection of 8, 9, 11, 12, 13. So, this way we will be able to get the alpha cut of a fuzzy set. Now, when we are interested in making this alpha cut a strong, means strong alpha cut. So, for alpha is equal to 0.6, we will have collection of all those points for which their corresponding membership value is more than or greater than 0.6. So, we will not be taking those values for which alpha is equal to 0.6. We will be taking only those values, only those generic variable values for which alpha for which the membership value is more than 0.6. So, we will exclude in the previous case we have included those values for which the corresponding values of the membership was equal to 0.6. Here in this case we will include. So, this way A, the strong alpha cut, strong 0.6 cut will be collection of 8, 9, 11, 12. So, this way we will be able to find out the alpha cut and strong alpha cut of a fuzzy set. Let me go through alpha cut and strong alpha cut little bit again. So, alpha cut of a fuzzy set that we had already seen is defined by A alpha is equal to the collection of all the x values here provided their respective membership values are greater than or equal to alpha. So, what does exactly this mean is that we have to collect all the generic variable values of a fuzzy set for which the respective or the corresponding membership values are either equal to alpha or more than alpha, and this is called alpha cut of a fuzzy set. So, let us now understand alpha cut more clearly with this diagram. So, here we have a fuzzy set A, and if we are interested in finding the alpha cut of this fuzzy set, that is A. So, we will first look for the value alpha, and alpha will always be a value which can be either 0 also, but normally more than 0, and it can go up to 1. So, let us say our alpha is some value here which is in between 0 and 1, and then we will look for the corresponding generic variable value which is a here. So, this will be the generic variable value for which the membership value is equal to alpha. So, this will be the start, and then we will take up all the values of x, that is the generic variable. So, all the values of x for which the alpha is either the membership value is either equal to alpha or more than alpha. So, for this fuzzy set A, we clearly see that we get another point B here, which also has the corresponding membership value alpha. So, in between and including A and B, we get all the values of the generic variable for which we have the respective or the corresponding membership values either greater than alpha or equal to alpha. So, that makes the sense here as to include all the values of the generic variable right from A up to B. So, since this is a continuous fuzzy set, and therefore, we can have the infinite number of such values of generic variable. So, that is why this has been shown by a line, and if we look at the terminal of this A B, the line A B, the terminals are the solid dots. So, solid dot would indicate here that the A is also included, point A is also included, and B is also included in the alpha cut of the fuzzy set. So, this has to be noted here that alpha cut is a set of all the values of generic variable, and this will not contain the membership, their corresponding membership values. So, only the alpha cut will contain only alpha cut is the set which will contain only the generic variable values. Now, if we talk of a strong alpha cut of a fuzzy set, so here we make a little change, and that is the equality, that is equality is not there. So, this means that if we are interested in finding a strong alpha cut of a fuzzy set, first of all we define a strong alpha cut of a fuzzy set by A alpha dash. So, dash is the difference here as compared to the alpha cut. So, if we talk of a strong alpha cut, the this will be represented by A, the A of capital A alpha and then dash, and this will be equal to the collection of all the points of the generic variable values for which their respective membership values are greater than alpha. So, this is to be noted that here the membership values, the respective membership values are greater than alpha. here equality sign is not there. So, this is the difference in between the alpha cut and strong alpha cut. So, if we take a fuzzy set here in this example, we have fuzzy set A, and if we are interested in finding out strong alpha cut of a fuzzy set. So, please understand that since the equality sign is not there, only the membership values which are greater than alpha are included. So, that is why, as we have already discussed in the alpha cut, the line A and B here will be the strong alpha cut, but the terminals of this line A and B means the start of this line at A and end of this line at B will be represented by a hollow circle. It means the point A is not included and B is not included. So, it is not included because exactly at the point A, the generic variable value point A, we have the membership value, the corresponding membership value alpha. So, that is why it is not included, because equality sign is not there. So, we are only considering those values of generic variables for which their respective membership values are greater than alpha. So, now I think this is very clear difference in between the alpha cut and strong alpha cut of a fuzzy set. Here also we see the clear difference in between alpha cut and strong alpha cut. So, we see how is it defined, the equality sign is here, see the equality and greater than, but in alpha cut here we see only the greater than sign is there. So, this way we understand this very clearly. Now, there is another way of understanding this, if we are interested in A1, A1 means the one cut of a fuzzy set A, but this has to be a normal fuzzy set because alpha is equal to 1 has been taken here. So, if we take an example here and if we have a fuzzy set, let us say A, this is a fuzzy set A, and if we are interested in alpha cut, this will be the alpha cut here, this can be small a, this can be small b. So, alpha cut is this line A and B. And strong alpha cut, as I have already explained, this A here and B here will be the strong alpha cut. So, we also have if we are interested in finding A1. So, A1 means the one cut of the fuzzy set. So, one cut of the fuzzy set A. So, this will have all those points, this will have the collection of all those points for which their corresponding membership values are equal to 1. So, obviously, the core is also the same. So, we can say that a core of A is equal to the alpha 1, means one cut of a fuzzy set A. Similarly, the support of A can also be defined in terms of the strict alpha cut. So, if we take the value of alpha here as 0, all right. So, now this is exactly the same thing was explained, and through diagram you can understand it little bit more clearly. So, at this point we would like to stop for this lecture, and in the next lecture we will be discussing the remaining nomenclatures used in the fuzzy set theory. So, it means we will be moving ahead to discuss remaining nomenclatures. Thank you.